Data comparisons with box plots. So here we have a box plot for dataset A and a box plot for dataset B. So they're comparative box plots because they're on the same diagram. We want to complete the table below. So if we look at dataset A, the minimum appears to be at 15. The lower quartile is the left-hand end of the box, so that seems to be at 19. The median is at 20.5. The upper quartile is at 21.5, and the maximum value is 25. If we look at dataset B, 15.5 seems to be the minimum. The lower quartile is at 18.5. The median is the same as the one above, so that's 20.5. The upper quartile is 21.5, and the maximum data value was at 22. Make comparisons between the two data sets. Well, there's all sorts of things we could say here. We can say the minimum value for A is less than that of B, and the maximum value for A is more than that of B. We can say that they have the same median, that they have the same upper quartile. If you know how to work out the range from a box plot, the range is the entire length of the box plot from this whisker to that whisker. That's the range, so the range of dataset A is greater than that of B. But if we look at the interquartile range, which is the length of the box itself, the interquartile range for B is greater than that of A. So there's lots of things that you can say. Match each box plot to a histogram. Now it's important to remember when we have a box plot that you get 25% or thereabouts in each section. Remember, quartiles split the data into quarters. So depending on how many pieces of data you get, you'll get more or less exactly 25% on each section. So between the lowest value and the lower quartile, between the lower quartile and the median, median and the upper quartile, and the upper quartile and the highest value. So when we have a data set like this, which we call positively skewed, where most of the data is at this end and less going out, you'd expect to have a box plot like this one, because we can see that 50% of the data is at this end. So these two are going to match together. If we look at this one, which is what we call negatively skewed, most of the data is at the right-hand end, and we can see here 50% of the data is squashed towards the right-hand end. So it makes sense that these two match. Now the other two are symmetric. So we have to make a distinction between this one and this one. Now if we look at this one, the data is more towards the ends. So we're going to expect the middle of the box plot to be more spread out. Now there's only one matching to make, which is this one. Does it fit? Most of the data is in the middle, and the box is much smaller, but remember, still contains 50% of the data. So that makes sense to match those two.